To meet explosion-proof standards for low-voltage signal connections in explosive environments, it is essential to understand which standards agencies and resources to consult. Firstly, for standards agency recognition, Underwriters Laboratories, or UL, provides a widely recognized certification program for explosion-proof products. Secondly, the National Fire Protection Association, or NFPA, develops standards related to fire protection and explosion prevention, including NFPA 70, the National Electrical Code. Thirdly, the National Electrical Code, or NEC, defines minimum safety requirements for electrical systems and installations, including those in explosive areas. Now consider explosion-proof enclosures. The first standard you should consider is UL 50.50E, which is the standard for electrical enclosures for use in hazardous classified locations. NFPA 70, or NEC Article 501, covers general requirements for electrical enclosures at hazardous locations. IEC 6007090 is the international standard for flame-proof enclosures, which can also be used for explosion-proof applications. When selecting connections, consider UL 514B, the standard for intrinsically safe electrical equipment. NFPA 70, or NEC Article 504, addresses hazardous area classification and installation requirements for intrinsically safe circuits. IEC 60079-14 is the international standard for explosion-protected electrical installations, including provisions for cable connections. Some additional resources include the Occupational Safety and Health Administration, or OSHA, which enforces standards related to workplace safety, including those for hazardous locations. Factory Mutual Global, or FM Global, provides certification and loss prevention services for explosion-proof equipment. The Explosion Protection Technologies Association, or EPTA, is an industry association dedicated to promoting explosion protection knowledge and best practices. It is recommended to consult with a qualified electrical engineer or an explosion protection specialist to ensure compliance with all applicable standards. Consider obtaining certification from a recognized standards agency like UL to enhance the credibility and marketability of products. It is critical to stay updated with the latest industry standards and regulations to ensure continuous compliance. Therefore, understanding these standards and resources will provide a solid starting point for achieving explosion-proof compliance. This includes understanding the roles of UL, NFPA, and NEC in recognition and the specific standards for enclosures and connections such as UL 50.50E, NFPA 70 Article 501, IEC 6007090, UL 514B, NFPA 70 Article 504, and IEC 60079-14. Furthermore, utilizing resources like OSHA, FM Global, and EPTA will contribute to a comprehensive approach to explosion protection. Ensuring that products meet explosion-proof standards is a multifaceted process that demands adherence to specific guidelines and regulations set forth by recognized agencies and organizations. To begin with, the selection of the appropriate standards agency for explosion-proof recognition is a crucial first step. Underwriters Laboratories, or UL, stands out as a widely recognized entity in this domain. UL offers a robust certification program tailored for explosion-proof products, providing manufacturers with a pathway to demonstrate compliance with industry benchmarks. This certification not only enhances the credibility of the product but also assures potential customers of its safety and reliability in hazardous environments. Another key player in the realm of explosion protection is the National Fire Protection Association, or NFPA. NFPA plays a pivotal role in developing standards that address fire protection and explosion prevention. Among its significant contributions is NFPA 70, more commonly known as the National Electrical Code, or NEC. The NEC serves as a foundational document, providing guidelines and requirements for electrical installations, including those situated in areas prone to explosions. Compliance with NFPA standards is essential for mitigating risks and ensuring the safety of personnel and equipment. In addition to UL and NFPA, the National Electrical Code, or NEC, itself holds significant importance. As a comprehensive set of regulations, the NEC outlines the minimum safety standards for electrical systems and installations, particularly those located in explosive environments. Adherence to the NEC is not only a matter of compliance but also a proactive measure to minimize the likelihood of electrical hazards and explosions. When it comes to explosion-proof enclosures, several standards offer guidance on design, construction, and performance criteria. UL 50.50E is a prominent standard that specifically addresses electrical enclosures intended for use in hazardous classified locations. This standard sets forth requirements for enclosure integrity, sealing, and other critical factors to ensure that the enclosure can effectively contain an explosion without propagating it to the surrounding environment. NFPA 70, or NEC Article 501, provides comprehensive coverage of general requirements for electrical enclosures situated in hazardous locations. Article 501 outlines specific guidelines for enclosure selection, installation, and maintenance to minimize the risk of explosions and electrical hazards in these environments. Furthermore, IEC 60079 serves as an international standard for flame-proof enclosures, which can also be adapted for explosion-proof applications. This standard specifies the design, testing, and marking requirements for enclosures intended to contain explosions and prevent their propagation to the external atmosphere. In addition to enclosures, connections play a vital role in maintaining the integrity of explosion-proof systems. UL 514B is a standard that focuses on intrinsically safe electrical equipment. This standard sets forth requirements for the design, construction, and testing of intrinsically safe circuits and equipment, which are designed to operate with limited energy to prevent ignition in hazardous atmospheres. NFPA 70, or NEC Article 504, delves into hazardous area classification and installation requirements for intrinsically safe circuits. Article 504 provides guidance on selecting and installing intrinsically safe equipment in accordance with the specific hazards present in the environment. Internationally, IEC 60079-14 addresses explosion-protected electrical installations encompassing provisions for cable connections. This standard outlines the requirements for selecting, installing, and maintaining cable connections in hazardous locations to ensure that they do not compromise the overall safety of the installation. Beyond the standards themselves, several additional resources can aid in achieving and maintaining explosion-proof compliance. The Occupational Safety and Health Administration, or OSHA, plays a critical role in enforcing standards related to workplace safety, including those applicable to hazardous locations. Compliance with OSHA regulations is essential for protecting workers from the risks associated with explosions and electrical hazards. Factory Mutual Global, or FM Global, offers certification and loss prevention services specifically tailored for explosion-proof equipment. FM Global's certification programs provide independent validation of product performance and adherence to industry standards, enhancing the credibility and reliability of explosion-proof equipment. Furthermore, the Explosion Protection Technologies Association, or EPTA, serves as an industry association dedicated to advancing knowledge and best practices in explosion protection. EPTA provides a platform for industry professionals to collaborate, share insights, and stay informed about the latest developments in explosion protection technology and standards. In conclusion, ensuring compliance with explosion-proof standards requires a comprehensive understanding of the relevant standards agencies, enclosure and connection requirements, and available resources. By adhering to standards such as UL 50.50E, NFPA 70 Article 501, IEC 60079-0, UL 514B, NFPA 70 Article 504, and IEC 60079-14, and leveraging resources like OSHA, FM Global, and EPTA, manufacturers and users can effectively mitigate the risks associated with explosions in hazardous environments. Seeking guidance from qualified electrical engineers or explosion protection specialists is highly recommended to ensure full compliance with all applicable standards and regulations. These professionals can offer valuable insights and assistance in navigating the complexities of explosion protection and ensuring the safety of personnel and equipment. Moreover, Continuous monitoring and updating of industry standards and regulations are essential to maintain ongoing compliance and adapt to evolving technologies and best practices. By prioritizing safety and adhering to established standards, organizations can create safer working environments and minimize the potential for catastrophic incidents in hazardous locations. Explosion-proof standards are a critical aspect of ensuring safety in environments where there is a risk of explosion due to flammable gases, vapors, or dust. Understanding and implementing these standards is essential for protecting people, property, and the environment. The standards are developed by various organizations, including Underwriters Laboratories, or UL, the National Fire Protection Association, or NFPA, and the International Electrotechnical Commission, or IC. These organizations establish the requirements for designing, testing, and certifying equipment and systems that are intended for use in hazardous locations. One of the key aspects of explosion-proof standards is the classification of hazardous locations. These locations are classified based on the type and concentration of flammable substances present, as well as the likelihood of an explosive atmosphere occurring. The classification system helps to determine the appropriate level of protection required for equipment and systems used in these locations. In the United States, the National Electrical Code, or NEC, defines hazardous locations as Class I, Class Roman II, and Class Roman III. Class I locations are those where flammable gases or vapors are present or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class Roman II locations are those where combustible dust is present or may be present in the air in quantities sufficient to cause an explosion or fire. Class Roman III locations are those where easily ignitable fibers or flyings are present, but not likely to be suspended in the air in quantities sufficient to produce ignitable mixtures. Within each class, there are divisions that further define the degree of hazard. Division 1 locations are those where the hazardous substance is present continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are those where the hazardous substance is present only under abnormal conditions, such as equipment failure or accidental release. Explosion-proof standards specify the design and construction requirements for equipment and systems used in hazardous locations. The basic principle is to prevent an explosion from occurring or, if an explosion does occur within an enclosure, to contain it and prevent it from propagating to the surrounding atmosphere. Explosion-proof enclosures are designed to withstand the pressure of an internal explosion and to prevent flames or hot gases from escaping and igniting the surrounding atmosphere. These enclosures are typically made of heavy-duty materials such as cast iron or steel and are designed with tight-fitting joints and seals. Other protective measures include intrinsically safe circuits, which limit the amount of energy available to ignite a flammable atmosphere, and purged and pressurized systems, which use air or inert gas to keep flammable substances out of enclosures. Compliance with explosion-proof standards requires careful attention to detail and a thorough understanding of the requirements. It is essential to select equipment and systems that are certified for use in the specific hazardous location and to install and maintain them in accordance with the manufacturer's instructions and the applicable codes and standards. It is also important to train personnel who work in hazardous locations on the hazards involved and the proper procedures for working safely. Explosion-proof standards are constantly evolving to keep pace with advances in technology and changes in industry practices. It is important to stay up to date on the latest requirements and to ensure that equipment and systems are compliant with the most current standards. In addition to the organizations mentioned earlier, there are other resources available to help companies comply with explosion-proof standards. These include industry associations, consulting firms, and testing laboratories. These resources can provide guidance on selecting equipment, designing systems, and conducting hazard assessments. Compliance with explosion-proof standards is not only a legal requirement, but also a moral obligation. By taking the necessary steps to protect people and property from the hazards of explosions, companies can demonstrate their commitment to safety and create a safer working environment. In conclusion, explosion-proof standards are essential for ensuring safety in hazardous locations. By understanding and implementing these standards, companies can protect people, property, and the environment from the devastating effects of explosions. The standards are developed by various organizations and specify the design, construction, and testing requirements for equipment and systems used in hazardous locations. Compliance with these standards requires careful attention to detail and a thorough understanding of the requirements. Staying up to date on the latest standards and seeking guidance from experts are essential for ensuring compliance and creating a safer working environment.